All right, this here is our unit circle. These triangles can be placed on that unit circle for these degrees. All right, so on a unit circle, the radius is 1. So for all these triangles, your radius is 1, or which is your hypotenuse here. Now, let's make a triangle, just a generic triangle that you kind of could put in here. It's a little bit too big. But if we make that generic triangle, we'll call this angle theta. It's 90 degrees. And, well, do you guys hopefully understand that this side right here of a right triangle, opposite of the 90, is called your hypotenuse? I'm going to abbreviate it as hype. That's your hypotenuse. It's always opposite in the 90. All right. Now, okay, the side opposite the angle is called your opposite. So the opposite's right there. So we're going to call that your opposite, your OPP. Yeah, you know me. Now, next we have the one next to. Well, since the hypotenuse is also next to, this one's adjacent to it. Adjacent means next to. So we'll call that our adjacent is the common name for it. And we'll call it adj for adjacent. So those are important pieces to see. So when you look at sine, well, if you think back to sine, well, there's this thing called SOHCAHTOA. SOHCAHTOA. All right? So when you think of sine, sine is opposite over hypotenuse. Opposite over hypotenuse. Cosine is adjacent over hypotenuse. All right? And tangent is opposite over adjacent. They're fractions. They're ratios of right triangles. And right triangles are all similar, so those ratios hold through proportionality. Okay, so, well, for this particular picture, let's look at it more. If we put this on this piece, do you understand the opposite? If I drew a triangle right here for all these triangles, isn't the opposite the y value? So couldn't we also call the opposite, couldn't we also call it the y value? And couldn't we call the adjacent the x value? And couldn't we call hypotenuse 1, because it's a 1 unit circle? So again, if we put this triangle right here, this is your opposite, which is the y, the height, and this is your x. So we can abbreviate these as, well, this one's going to be the opposite, which is the y divided by 1, which reduces to y. This one is going to be x over 1, which reduces to x. And this one becomes, well, the opposite's y, y over x. And these are what we're going to start calling them. Back in Math 3, we called it these. We're going to start calling them y, x, and y over x. Now, we still want to know these, but this is what we're going to start calling it. We see sine, we're talking y. If we see cosine, we're talking x. If we see tangent, we're talking y over x on a unit circle. And look right here. Isn't that x, y? X, y. X, y. This unit circle has all your sine values hiding in it. I want to find the value of this trig function. First thing I want to do on my unit circle is to find 120 degrees. Okay, so 120 degrees starts here, and we're going to wrap around. That's 90, 120 is right there. Okay, now, so I want sine of 120 degrees. Well, if you were to draw a little right triangle here, it could help you visualize, if you want to. And that little right triangle can help you find the coordinate at the edge. So at the edge there, hopefully you see that coordinate. Well, that coordinate is over a half and up square root 3 over 2. So it's over negative 1/2, because your x is negative, and your y is up square root 3 over 2. Now, here's the thing. When we talk about sine, aren't we asking for the y value of this coordinate? So isn't that the y value? So what is sine 120? It's square root 3 over 2. It's that number right there. Done. So we are going to find cosine of negative 210. First thing I got to do is find negative 210, and then we'll find the cosine, which is the x value of that terminal point. Okay, so we start here when we're at 210. 210 is bigger than 180, so I go here to 180, and then from 180 I want to go 30 more, so I'm right there. So that is what I'm looking for. I'm looking for that coordinate at the edge. So what is that coordinate at the edge? Well, if we think about it, if we drew a little right triangle here, it can help. For that right triangle there, isn't the x value bigger than the y value? So isn't the x value going to be a negative square root 3 over 2, and isn't the y value going to be up 1/2? And for cosine, aren't we looking for the x value? Aren't we looking for that value right there? So it's going to be negative square root 3 over 2. Let's find the value of tangent 180 degrees. So tangent is y divided by x, but we first have to find 180 degrees. Okay, so here we go. 180. We start here. 180 means I go right there. Okay, there's my terminal point. What coordinate is that? Well, that coordinate is pretty easy, negative 1, 0. I like it when it hits the edges. All right, now this is my x, this is my y, and tangent is y divided by x. So isn't that going to be 0 divided by negative 1? Isn't that equal to 0? So tangent 180 is 0. Done. So we want cosine of 3 pi over 2. So let's find 3 pi over 2. So right there, 3 pi over 2, well, that's 1 pi, and I want 1.5 pi, so there we are. I want that right there. Okay, the coordinate down there is 0, negative 1. And if I'm asking for cosine, I want the x. So I want that number right there, so my answer is 0. I want to find sine of this. Now, that's a little weird looking, so I'm going to actually change that to a coterminal. I don't like that one. So what I'm going to do is I'm going to take negative 9 pi over 4, and I'm going to add 2 pi. Now to add 2 pi, I want a 4 on the bottom. Wouldn't that be 8 pi over 4? So when I do that, negative 9 plus 8 is negative 1 pi over 4. Now, if you still don't feel comfortable with negative pi over 4, you could add 8 pi over 4 again. But for me, I think I can do that. I think I can go, okay, I start here, and I'm going down a fourth. So I think that's okay. I'm right there. And I can do the coordinate at the edge. So that coordinate would be what? Positive square root 2 over 2, and down negative square root 2 over 2. And lastly, I want sine, so I want this value, the y. So my answer is negative square root 2 over 2. Again, you could have changed this and gone to this way around, another coterminal value instead of that. It's your call, whatever you need in order to get this point, and then sine wants that value, the y. So tangent of 2 pi over 3. So let's find that. 2 pi over 3. So right here, boom. 2 pi over 3 means 2/3 of pi. So that's 1/3, and that is 2/3. So there we are. We want this coordinate over there. So let's write out that coordinate. That coordinate, if I drew it out, to me means I went over a half, so over a negative 1/2, and I went up the square root of 3 over 2. So that is x, that is y, and tangent is y divided by x. Okay. Ooh, this one's a little bit uglier. So I have y, which is the square root of 3 over 2, divided by x, which is negative 1/2. All right. Now, okay, that means divide means I'm going to flip and multiply. So I'm going to change that to a multiply of negative 2 over 1. These cancel. don't lose that negative. It looks like I got negative square root 3 over 1, which means my answer is negative square root of 3. So that is the answer to tangent 2 pi over 3. I hope you can see making this in this fashion is a little bit easier than putting a fraction over a fraction. And as you do more and more tangents, this answer comes up quite often. So just be aware of this. This is a common answer to tangents. And keep that in the side of your brain, kind of remembering, oh, square root of 3 might be an option.